Okay, let's resume. This chapter is about using OO concept and Java language to create graphical user interface elements. So far, you have been writing application that generates command line interface. Command line interface is like Linux or Unix, whereby you type in values or you type in some commands to make the application work as intended. But nowadays, most applications come with graphical user interface. Now, when you develop the functions of an application, usually you will do it in command line because it's easy to do testing in command line. But when you want to deliver to your client nowadays, even if they are technical, they prefer something that is graphical, isn't it? So that's when you create the graphical user interface as a layer on top of the function, so that this graphical user interface can be used to control the functions or the methods or the objects underneath. How do we do that? Now, in order to learn GUI, first we need to get hold of the GUI libraries or GUI packages. Then you need to know how to import these packages into your programming environment. And number three, you have to record all your OO concepts in order to use them effectively. What have you learned about OO concepts so far? Have you learned encapsulation? Have you learned inheritance? Right? Have you learned some polymorphism? Yes. So we will use these concepts to reuse the classes inside the GUI package effectively. Do you remember that we have to create objects from classes, and then from the objects we call the methods, right? Now, at that time, we are talking about a general class, a general object. Today, we'll be just talking about classes and objects to generate the user interface that you see in Microsoft Windows, in your Mac OS, in your Android. Android is in Java, right? So whatever you see there in your Android, the OO concepts are similar. So these are the objectives, okay, of today's lecture. Number one, to learn about GUI container. Number two, to learn about GUI component. Number three, to add behavior to them. Three things only: container, component, add behavior. Now, this is a graphical user interface. Take a look at the labels. Please be mindful about which one is container and which one is component. Now, please take a look. What is a container in your opinion? The box, right? It is used to contain something. That's why it's called container. What is inside the container? The components. Can you give me an example of components from this graphics or diagram? Label, text, drop down, button, text area, button. Right? So these are components. Another name for components are widgets. Sometimes they call it widget. Yeah? Now, when you drag the component onto the container, you need to arrange them, right? Now, you can arrange them by putting them on certain coordinates. The coordinate of a container starts from 0, 0, which is on top left, not bottom left, from top left. That is 0, 0, just underneath the blue title bar, yeah? That is 0, 0. And then you can make use of layout manager. There's a an invisible layout manager that comes together with the container. Every container has a layout manager. The layout manager will automatically arrange for you. If you don't like the automatic arrangement, then you can disable the layout manager and then you can set X, Y coordinate for each of the components. But that one will be slow. You have to do, you have to test, okay, this X, Y coordinate and then see where the component appears on the container. But if you leave the layout manager there, it automatically arrange for you. But sometimes it can be annoying, especially if the arrangement is not something that you want. Yeah, there are a few layout managers, border layout, flow layout, and many more. We'll be looking at 1, 2 of them just to get the idea what a flow layout what a layout manager is. Yes.
So when you create like buttons and boxes, so it automatically sets the layout. So when you want to like move the position immediately.
Okay, the layout manager comes together with the container. You don't have to instantiate it. The moment you create a container object, for example JFrame or JPanel, it already has a layout manager. The default layout manager for JPanel is flow layout. Flow layout, we put the components side by side. You add the first component, you put on the left, and then add the next one, you put next to it. Next, and then if there's no more space, you go to the bottom.
So you don't have to, if you want to create button, you have to bind it.
You don't have to what?
Like bind the button. So to like flow.
Oh, the binding to the you mean bind to the behavior, is it?
Yeah.
Binding usually we're talking about behavior. You see, when you create a container and you add component, when you click on the component, nothing will happen because the component is not able to read the event. Now, what is event? Your mouse click, your typing, anything from the keyboard, anything from the mouse, anything that the computer can detect from the environment is called event. So these components, right, they don't by default detect the events. So you have to add code so that they can detect which event. Let's say this mouse will only respond to double left mouse click, or this button will only respond to scrolling wheel. You have to write the code to tell the component to listen to what event, and then if it has heard that event, what should it do? Which object, which method should it call? Which algorithm should it call? That's called binding to the handlers. Handlers are a set of methods. Handlers are a set of methods that you can bind to the component when an event occurs. Because the reason why we use GUI is because for interactivity. When I double click this, right click this, left click this, use scrolling wheel. If you use joystick, then probably you have to look at what you can do with joystick, right? And then after it detects, how should it respond? Trigger handler. So handler is basically a method that is bound to a component. Yeah? So we'll be looking at that. That will be the third objective.